Hello, this is an optional supplement to the two-sample t-test done in Minitab for those interested in seeing the underlying calculations. So we'll solve the same example, mix 1 versus mix 2. We're going to solve first the blue highlighted boxes, which is the two-sided alternative, and then we'll come back and solve the one-sided as well. So I'm just going to get started here. We're going to need to know the mean, standard deviation, and sample size for each. Obviously, we could just put in a 5 here, but just to avoid mistakes, I'll use count for the sample size. We'll use the STDEV function for the standard deviation and the average function for the mean. And just copy those over for sample 1 versus sample 2. So there's some of our summary statistics. In order to calculate the test statistic, since we're assuming equal variance, we need to calculate this S sub P, which is the estimate of the common standard deviation. If you like Excel and you like typing long formulas with lots of parentheses, you can do that in one line just to make things simple. I'm going to break it up and do the numerator here separately. So the numerator is n1 minus 1 times s1 squared plus n2 minus 1 quantity times s2 squared. And then that n1 plus n2 minus 2 is the degrees of freedom. So I'm just going to write nu. And that's equal to n1 plus n2 minus 2. We're going to need that later anyway. And so our estimate of the common standard deviation is the square root of the numerator divided by denominator. And that should agree with what was shown for the pooled standard deviation in the Minitab result shown on the right. So for the two sample, we'll make the two columns here. Sorry, for the two-sided alternative, they're both two sample. For the one-sided alternative, we'll make separate columns here. Test statistic in the two-sided case is y bar 1, so mean 1. It's going to be quantity mean 1 minus mean 2 divided by that SP, and you could use parentheses, but I'm just going to do another divided by square root of the quantity 1 over n1 plus 1 over n2. So that test statistic, negative 2.60, is the same value we see over here from Minitab when we were doing the two-sided alternative. Test statistic is the same regardless. So this is just equal to that. And then we're going to determine when we would reject the null hypothesis. And in one case, we're figuring out alpha. In the other case, we're figuring out alpha by 2. So I'll kind of key it up this way. Alpha by 2 here and alpha here, where alpha by 2 is involved in the rejection criterion for the two-sided alternative. For the one-sided, the only thing that changes is the rejection criteria is now alpha and negative. Right? So alpha by 2, got to remember the rejection criterion says reject if the absolute value of T naught exceeds T alpha by 2 with new degrees of freedom. So let's figure out what alpha by 2 would be. In other words, what value of alpha by 2 would make the rejection criterion exactly equal? What would make the T statistic with 8 degrees of freedom equal to 2.603? The absolute value of that. This is going to use the cumulative distribution, so we're actually looking for the right tail of it. So it's going to be 1 minus everything up to that. So it's going to be 1 minus a t dot dist of the absolute value of the negative 2.6. And that's with new degrees of freedom, and it is cumulative. So that's alpha by 2. And so, of course, alpha then would just be double that. And that's the 031 that Minitab was giving over here. For the one-sided alternative, we skip the step of alpha by 2 because the rejection criterion is just T naught less than negative T alpha. So in this case, if we just take the cumulative density up to the negative value, we don't need to do the 1 minus either. So this is just the T dot dist of the actual test statistic with 8 degrees of freedom and cumulative. So that's the 0157 number that you see here from Minitab. So it's just for anybody interested, that's what's going on behind the scenes, purely optional. Thanks.